In this video, I am going to use technology and how can you show your work during the proctor test. In our problem, we have a population, and from this population, we select a sample, and from this sample is given a data one by one. Let's do a simulation. Remember, when we obtain my data from the entire population, we have a census. All of these numbers represent the measurement of one characteristic in all members of this population. Each point represents one member of the population. Let's do a simulation. Suppose that this population, I know that the mean is 100 and the standard deviation is 2. If I measure this characteristic in all members of the population and we plot in a number line all of these points according to its measurement, I know that 100 will be here. It's possible that when I plot all of these points in this number line, I will obtain something like this. The majority of these points will be located close to 100 because the mean is 100. This is a bell-shaped distribution, and the standard deviation of the distribution is equal to, and according to the empirical rule, within 3 standard deviation to the right and 3 standard deviation to the left of the mean, exactly 106 and 94, between these 2 points, we have approximately 99.7% of all measurement of this population, all of these numbers. Here in StatCrunch, let's do a simulation, and the distribution will be normal, and we know that the mean is 100 because in simulation we know the parameter, and the standard deviation is 2. In this case, the seed is 12,641. I will explain later what it is. Let's use no decimals in my sample, and we are going to select from this population 30 observations. My sample consists in 30 observations. In this case, n is equal 30, and I am going to measure this 30 observations, and I am going to organize all of these observations in one table here in one column. And let's compute. We have here 30 observations in this column. Normally in a StatCrunch, when it's given a problem, it's given the data, and beside the data you can find this icon, and the meaning of this icon, when you click this icon, you can send the data either to StatCrunch or to Excel. You can use these 2 software during your proctor test, and you can use it to show your work. It's very important that you identify this little icon beside the data in all problems. We have selected 30 observations from the population. This population could have millions of items, and I selected only 30. These 30 observations were selected randomly from the population. First of all, to each member of this population, we are going to assign a number from 1 to whatever number. For example, if this population consists in 1 million of items, then this one could be the number 230, and this other one could have the number 1323, whatever. We can list in the census each member of the population with its corresponding number and its measurement of the characteristic in which we are interested. Or we can plot all of these points in this number line according each measurement to obtain this pile, this normal distribution. If we select 30 from this pile, 30 observations from this pile, you will notice in this simulation that all of these numbers are between 94 and 106. 3 standard deviation above and below the mean. All of these numbers are between 94 and 106. That is the empirical rule. What is the process that the computer and statistician use to select a random sample from the population? We use a random numbers. This is a section of table of random numbers. Here we have multiple columns of digits generated by a software. A software can fill all of these columns with digits between 0 to 9, to obtain multiple pages of random numbers. In this column, for example, we have 3, 4, 3, 8. A software can generate randomly this column with digit, any of these 10 digits, and so on. We can divide this column in group of 4 or 5, whatever, only for reference. And we can start at any point to obtain random numbers. Suppose that the population consists of 800 items. We use big case N. And from this population, we want to select a sample size 20. We are going to name each item of this population with one number between 1 to 800. And after that, we are going to start at any point in this table or any page of this table generated by the computer. For example, we can start here at this point, and that is the C that we were talking about at the beginning, the digit number 12,000. Then from this point, we can take any direction, down, up, to the right, to the left, diagonal, in any direction. We can select 20 observation. And suppose that we are going to select this direction, down. Because the population have only 800 items, then we need only 3 columns, column 1, column 2, and column 3. Then these 3 columns. If the population had only 80 items, then we need only 2 columns to obtain my random numbers. Then in our example, my first selection will be 803, because in the population we have only 800 items, doesn't exist item with this number. So we skip this number and we continue with 27. Suppose that this is the item we assign the number 27. Then this will be part of our sample. The next will be the item 183, the next 493, and so on until we obtain 20 items. In this list, this item and this item will be skipped, and we are going to continue with the next 3 columns, these next 3 columns. Then we are going to continue with this item, the item number 752, and we will continue it down in this way to obtain 20 observation or 30 observation or whatever number of observation. This is the most common way that a statistician and computer generate random samples. Then once you have collected your sample from the population and obtained your data from this sample, that are the measurement for each member of the sample, then we can organize, we can summarize, we can analyze, and we can draw conclusion about the population using this sample. We can organize the data using a frequency table, and we have to go to stat, table, frequency. My data is located in this column, compute, and we have our frequency table. Then we have 1 item 97, 4 98, 6 item 99, and so on. That is the frequency table. The minimum value is 97, the maximum value is 105. Most of the value actually are located between 98, 102. Also, we can obtain a histogram here in graph. Histogram, my data is located in this column, compute, and we have the histogram. Then in the histogram, you can observe that we have one item with a measurement of 90, between 96 and 98. Between 104 and 106, we have 3 items, 1, 2, 3. The class with the highest number of observation is the class between 100 and 102. We have 11 observations in this class. Also, we can change the width of this class. In this histogram, the width of all classes is 2 units, but we can change the width to 1 unit. Here in option, the width is equal 1 unit. That is the histogram when we change the width. StatCrunch also gives me the summary of the most important statistic. We have to go to stat, summary, then my data is located in the column normal 1, then compute. These are the most important statistics. Then here we have the mean, the variance, standard deviation, standard error. I will explain this later in chapter 6. Median, range, minimum value, maximum value, the first quartile, the third quartile. The second quartile, remember, is the median. But be careful, pay attention. I will allow you to use StatCrunch and Excel in all tests, including the Proctor test. Then you can obtain the answer very easy, but you need to show your work. You need to use formulas to obtain all of these statistics. For example, if I request in this problem, show your work, you need to do the following step to obtain the mean, the standard deviation, and all of these statistics. Let's show your work to compute the mean of this sample. The formula for the mean x bar is equal to the sum of all observations divided by my sample size. Remember, my sample size was 30. My first observation was 102. My second observation was 98, and so on. The last observation was 101. Despite of the result of all of this operation is 100.4, you need to verify this operation in Excel. Or if you want to use any calculator, you can verify. You must verify, but I strongly recommend to use Excel. Let's verify this result using Excel. Let's copy all of this data. In this occasion, I am going to use Ctrl+C, and I will open Excel, and Ctrl+V, and I have 30 observations here. It is important to verify those operations. You must indicate the operation, and you need to verify those operations. Then this is the random variable x, and here we are going to obtain the sum of these 30 observations is equal. We need to start always with equal, the sum, open parenthesis, of all of this value until here. We have 30 observations. Then the mean will be equal this sum divided by 30. Then that is exactly the value that we have in StatCrunch. Because an error, the bottom part of the screen doesn't appear, then I am going to do all operation in Excel. I am going to show you how can you verify all operation in Excel again. This is a different example, but I will show you only the steps in Excel. Let's start here in this cell, and in this cell I am going to copy equal sum of all of this value. Close parenthesis, this is the sum. In this short example, we have only a observation, then the mean will be obtained in Excel equal the sum of all value divided by a, and that is the mean. To show your work, the only thing that you have to do after you have verified all of this operation is this sum is equal 3012 divided by 30 will be equal 100.4. Let's obtain now the variance. The formula of the variance is this one. We need to obtain the deviation of each value respect to the mean, square all of the deviation. We need to sum all of the deviation square and divided by n-1, because this is a sample data. You need to split this formula. My first value is 102 and the mean is 100.4. We need to square this deviation. Then my second value is 98. Then this is the deviation respect to the mean. We need to square. Plus, you can continue it here. Plus, my last value is 101 minus the mean square, and that must divided by the sample size minus 1. This is equal to, you already have the answer in StatCrunch, but you need to verify all of these operations. You can do it using any calculator, but my strong recommendation is to use Excel. Then in this column we are going to write all deviation respect to the mean, x minus the mean. Then that is equal this value minus the mean. The mean is located here. If I want to copy this formula in all of this cell must be fixed using dollar symbol. In the cell B33 we have the mean of my data. We need to subtract the mean from all values. Then I am going to subtract from all of this value the value that I fix in these cells. Let's copy this formula in all of these cells, and we obtain all deviation. I didn't notice that my screen was cut in this presentation. Here we have in this cell, we have the sum of all of this value. This is the first value, that is the last one. And here we have in this formula the sum of all of this value, which is this, divided by 30. That is the formula. Always all formula must start with equal in Excel. Then here we have all deviation, and one important property of the mean is that when we obtain the deviation of all values with respect to the mean, the sum of all deviation, because some deviation will be positive, another will be negative, then the sum of all deviation should be equal 0. Always, doesn't matter how many values we have. If we sum equal the sum of all of the deviation, then the result is 0. The sum of all deviation is 0. For that reason, statisticians, they have to define another statistic, the variance, which is the average of all square deviation. Why? Because if we want to obtain the average of all deviation, we always obtain 0. Since the sum of all deviation with respect to the mean always is 0. Statisticians solve this problem obtaining the square of all deviation. Then let's write in this column the deviation with respect to the mean, but raised to the second power. Then here we have equal this quantity, which is the deviation, to the second power. And we can copy this formula here. Then these are all square deviation. Then the sum of all square deviation equal the sum of all of these square deviation, and that is the number that we need to write here. Then the variance is equal the sum of all square deviation, which is equal 109.2 divided by the total observation minus 1, in this case 29. Remember, if this data were a census, the entire population, we have to use instead this letter, the Greek letter, this letter, we have to use the Greek letter sigma, and sigma square is the population variance. And the formula is similar. Is each value minus the mean or deviation square divided by the total observation. And then in this case, we need to sum all of this value and divide it by 30. Then for that reason, the variance is the average of all square deviation, because this is a sample of a big population, 30 observation taken from a big population. Statisticians, they prove that when they subtract 1 unit from the total observation, this is a better estimator of the true variance of the population. That is the variance of my sample. Then the variance of this sample will be obtained dividing the sum of all square deviation divided by 29, and that is the value that we obtain in StatCrunch. Then we can write it in our work in this way: 3.76551. And the standard deviation formula is the square root of the variance, but the variance is have this formula, and the standard deviation is the square root. And the square root of the variance here in Excel, the standard deviation will be equal the square root in Excel. Square root is SQRT open parenthesis of this quantity, which is the variance, and is 1.94049. Then we have verified all of this result that we obtained in StatCrunch using formula. This is your work. You need to show your work in your tests in that way. Be careful with your answer. If the problem requests only 2 decimal, round this quantity to 2 decimal places. In this case will be 7.7, and this quantity will be 1.94. If you write more or less decimal, the answer could be wrong. You need to read carefully the instruction below the box where you have to input the answer. They specify the number of decimal that you need to write. There is a shortcut formula for the variance and standard deviation. The original formula for the variance is S square is the sum of all deviation respect to the mean square divided by n minus 1. We can transform this formula algebraically in this other formula: n the sum of all x square minus the sum of all x, all of the sum square divided by n times n minus 1. There is another one which transforms the sum in the numerator, the sum of all the deviation in this other sum, the sum of all square values minus n times the mean square divided by n minus 1. These are the shortcut formula. We are going to obtain the same result using the shortcut formula. The shortcut formula are easier to work with. Let's show our work using this shortcut formula for the variance. In this formula, we need n, that is given, the sample size. We need the sum of all x squared and the sum of all x. But the sum of all x, we already obtained the sum here in this box. We need to obtain only the sum of all x squared. Let's start from the beginning with our data. Let's copy our data in this column. Then the sum of all value will be equal. The sum of all value, we already did it, is the sum of all value in this column, and we already obtained 3012. And we need the square of all values. Then the square of all value is obtained using equal this quantity raised to the second power, and we can copy this formula in all of this. That is easier than the other one using the original formula. Then the only thing that we have to do is copy this formula of the sum here also, and we have all elements that we need for our shortcut formula. To show your work, you need to expand this formula in this way. You have 30 observation, which multiply the sum of all x squared. The first x squared, you can write it in this way: 102 raised to the second power, 98 raised to the second power. Then you don't have to copy all of them, the first two and the last two. 101 raised to the second power minus, then here you need to copy the same number but no raised to the second power, 102 plus 98, and the last one is 101. That is the sum of all value divided by 30 times 29. Then we can obtain this result. Then we substitute the sum of all square for this value, and in our formula we have 30 times 302,514 minus the sum of all x, which is 3012, divided by 30 times 29. Be careful, the sum of all x must be raised to the second power. Let's go to this cell. In this cell we need to start with equal, open parentheses in the numerator, n, which is 30 times the sum of all x squared that are located here, minus the sum of all x that are located here but raised to the second power, divided all this numerator divided by open parentheses 30 times 29. That is the denominator. That is equal, is exactly the answer that we obtained before. Then you must write in your work. The result is 3.76557. If you need to round this to decimal, is 77 approximately. That is your work using the shortcut formula. The standard deviation is the square root of the variance.